Hello everyone, my name is Stephanie Landazuri and today I'm going to talk about my research. Examining the relationship between STAT3 and estrogen receptor in osteoclast function and development. Osteoclasts and osteoblasts are cells responsible for bone formation and reabsorption. Here's an overview of my project. And as some of you know, menopausal women who no longer experience their menstrual cycle have low levels of estrogen in their body. And they are at the higher risk of developing osteoporosis, a condition in which their bones have a lot of holes. Thus, their bones are easily to fracture. Osteoporosis is due to an increase of osteoclastic activity, but the relationship between the osteoclast and the estrogen is not clearly defined. And we have recently showed that a female mice with the signal transducer and activator transcription 3 delivered from osteoclast have show weaker bones than the wild type or control mice. But there was no difference between the knockout STAT3 versus the control male mice, suggesting that STAT3 might be involved in the signal pathway between estrogen and osteoclast development. So we developed the hypothesis that the loss of estrogen during the menopausal stage disrupts the STAT3 signaling pathway, resulting in an increase of osteoclastic activity or cell survival. So to validate our hypothesis, we use the pre-osteoclastic growth 264.7 cell line and knock out the STAT3 using the CRISPR-Cas9 system. The knockout of STAT3 in raw cells were co-transfected with HDR plasmid, carrying puromycin-resistant gene. And we are in the process to confirm the loss of STAT3 expression using the real-time quantity PCR. We used also flow cytometry to examine the cell death and using FIXI antibody specific to the annexin 5 as well-known test for apoptotic cell. So here are the STAT3 knockout raw cells treated with alendronate and 17-beta-estradiol. As you can see here, we have there are more apoptotic cells compared to the controls. We can observe that the knockout STAT3 has a 14% apoptotic cells when it's treated with alendronate and a 12% when it's treated with estradiol, compared to the 7 and 8% respective controls. So, as alendronate has been used to treat osteoporosis patients by slowing down the osteoclastic activity in bones, but the mechanism of alendronate is not clearly defined. But we believe that it might affect the STAT3 pathway. So in conclusion, the CRISPR-Cas9 was used to knock out STAT3 gene in raw cells, followed by the real-time quantity PCR to confirm the loss of STAT3 expression. The knockout STAT3 in raw cells treated with alendronate and estradiol show an increase of cell death, suggesting that STAT3 plays an important role in estrogen-induced osteoclast apoptosis. Estrogen's main function is to prevent the bone loss through inhibition of osteoclast bone reabsorption and activity. In our future experiments, we will investigate how STAT3 regulates the pathway that estrogen receptor alpha induce apoptosis in osteoclast. We will repeat our experiment again, and we will analyze the gene expression between the cells treated with alendronate and 17-beta-estradiol and control and knockout STAT3 by using the real-time PCR. I want to acknowledge the support from QD Research Program and from my mentor, Dr. Andrew Wan. Thank you for listening. Any questions?